This is the UML class diagram of the 5 classes of our program. It shows the main functions and the variables within each class. As you can see, we have a user class and then 2 classes, the artist and the administrator, which inherit from the user. We have a song class and we have a playlist class, which has an aggregation relationship with the song class. And then the user has an aggregation relationship with the playlist. So the user can have many playlists and each playlist can contain many songs. There is also an association relationship between the artist and the song. When the artist publishes the song, that song is now associated with that artist and it contains the name of the artist that published it. Shown in each class are the variables and the main functions of each class. For example, the user can play songs, rate songs, add playlists, display playlists, and get the number of users. The artist can do anything that the user can do, but on top of that they can publish songs. The administrator can also do anything that the user can do, but on top of that they can delete users. A song can be either played, rated, or its info can be displayed. And a playlist, you can add songs to it and you can display all the information about the playlist. Also, you can see all the variables within each class. For example, in the user we have the number of users, which is a static integer. This shows the total number of users that are currently in the database. We have a username, which is a string, and this is protected so that it cannot be seen by the public. However, it can be inherited by the artist and the administrator, as well as a vector for playlists, which allows each user to store a number of playlists. The artist also has a number of songs that they published, which is in a public integer. This is because we want other users to be able to see how many songs an artist has published. They also have a vector of all the songs that they have published just to keep a record. A song will have a constant integer for its duration because we don't want the duration to change and mess things up, so we want that to remain constant. We have an integer for the number of times it was played, a vector of floats as a rating, the genre, which is a string, the name, which is a string, and the artist name, which it inherits from the artist that publishes it, which is also a string. And then lastly we have the playlist, which just contains a name, which is a string, and a vector of all the songs within the playlist. Over here we have the code for our program. There is a .h and a .cpp file for each of the classes, as well as the main.cpp, just for testing all of the functions. To demonstrate the principle of data hiding, we put the variables into private. This basically means that they are not going to be seen by other users and they cannot be accessed by other objects, whereas the functions will be in public because they can be accessed by other objects. This isn't just for the song class, it can also be seen in all the other classes, similarly enough. The one exception is the user class, where we have the variables under protected, so that the artist and the administrator can access them. Here in song.h we can also see that there are many different overloaded constructors. This allows the creation of a song object with a different amount of parameters. For example, if I switch over to song.cpp, we can declare a song object with nothing. That'll be the default constructor, and then default values are given to all the different variables. Whereas if we have an overloaded one, we can have a name, which is a string or an integer for the duration, or we can have a name, a duration, and an artist name, or a name, duration, artist name, and genre. And these can either be specified through the constructor via the overloaded constructors or later on using setters. In the song we can also see that we have a constant integer for the duration. We want the duration of the song to remain constant at all times. Because it is a constant, it cannot be changed once the song object is declared. Therefore, it is initialized differently. As you can see in the song.cpp, the integer for the duration is passed in normally, like any other variable. However, there's a colon and then the duration is initialized separately. And this is done in all of the constructors to allow the constant to be initialized and set. An example of the association relationship can be seen right here. In the artist class we have a function called publish song, and the song gets passed in as a parameter. The set artist name is called on the song with the username of the artist passed in as a parameter, and this associates the song with the artist. For the composition or the aggregation relationship, we go into playlist.h, and we can see that there is a vector that contains a list of all the songs in the playlist, and every time you add a song through the add song function, which you can see right here, it puts that song, which is passed in as a parameter, into a vector of songs. And the same goes for the user, which can have a vector of playlist. Each user can have many different playlists, and the playlist is passed in through the add playlist function, which, as you can see right here, just adds the playlist to the vector of playlists in the user class. This way each playlist can contain many songs, and each user can have many different playlists. For inheritance, we have a parent user class which contains many different functions, and then two different child classes, which is the artist, which can access all of the functions and variables of the user class, but has its own separate functions as well, such as the ability to publish a song. This is declared right here in this line. The artist class inherits from the user class, and the same goes for the administrator. It inherits all of the functions and variables from the user class, as well as having its own function to delete a user. With the inheritance relationship, we can also see an example of function overriding. In the user class, we have a function called displayUser, and if we go to the CPP, we can see what it does is it displays the username of the user. However, we can see we also have this display function overridden in the artist. And if we go into the artist, it's the exact same function. It's the same function name. It just overrides the user display user, which it inherits from the user. So as we can see here, for the artist, it will display, first of all, we'll say that it's an artist. Second of all, it will display the number of songs, and this differentiates it from the regular user class. And the administrator also has a display user function overridden. So as we can see in the administrator.cpp, it shows that it is an administrator instead of just a regular user. These are both things that are common to an inheritance relationship. You'll have overridden functions for different classes within that inheritance relationship to differentiate them. Lastly, we have an example of a static variable. In this case, it is the number of users. A static variable is very similar to a global variable, whereas it can be accessed even outside of the class in which it is declared. So for our example, we have a static integer for the number of users. Each time in the constructor, every time a user is created, that static integer gets incremented. This is also true for any of the classes that inherit from the user class. So every time an artist or an administrator will be created, I'll also increment it. That static integer will be accessible to all user objects. It will be basically shared amongst them. So at any point you can call the getNumberOfUsers function from any one of the objects, from any one of the user, administrator, or artist objects, and you'll be able to see the total number of users. So lastly, we have our main.cpp, in which we test all of the functions in the program. So if we give it a quick cheeky little build and run, as you can see, it compiles, no problem. So here we have side by side the main.cpp as well as the actual program running that we use to test all the variables. So first thing we did is created two song objects, song S1 and S2. And as you can see, they have different length, different number of arguments in the constructors, which is an example of constructor overloading. And as we can see, we put in the song name The Root Sandstorm because we're funny. The artist unknown, the genre, which doesn't actually get displayed, and the time in seconds. And as we can see, Over here we have the name, Druid Sandstorm, artist unknown. Duration is 5 minutes 24 seconds, which is 324 seconds. And the times played is 0. It hasn't been played yet, only just been created, as well as rated 0 out of 5. Makes sense. And the song also has artist unknown, because that's the default artist, because we didn't put in any artist. And the song name is La La La. And 7 minutes 12 seconds, which is 432 in minutes and seconds. And as we can see, there's the code to display for the display functions for the two songs. Then we created two users. As we can see, first, if we just call the number of users variable, the static variable, it says number of users is 0 because we haven't created any users yet. Then once we create our first user, which is Rafael Wolk, whoever that is, the number of users then increases to 1 after we call it again. The number of users increases to 1 in that static variable after we call it from user 1, which is that user. And then we create a second user, which is an artist, Sebastian, and we call once again from the first user. As we can see, the number of users does in fact increase, even though we just created a different object, which is an artist, which inherits from the user. Then, as we can see, if we call the display user function from the user, we get username Rafael Volk. Then we created a third user, which is an administrator object, named it Betsy the cow. Once again, we're very funny. And if we once again call get number of users from user 1, we can see that it increases to 3. And then when we display the user for the admin class, we can see it says administrator username Betsy the cow, an example of an overridden function. Same with the artist. If we display user, we get the artist username as well as the number of songs 0. Next up, we have examples of the association relationship. If we then publish the two song objects, S1 and S2, through artist1, we can see, if we then display user for the artist, we can see the artist number of songs increases to 2, because we now have published 2 songs, and this is just to keep track of the number of songs. And if we then display the list of all the songs by that user, we can see the artist name and the name of the song, and they've all been published by Sebibi, so they'll all have that as the artist name. So if we once again call the same functions, S1 display detailed, S2 display detailed, we'll now see song 1 and song 2, the artist changed to the artist name of the artist that published it. Then lastly, we have the playlists. So if we create a playlist object and give it a name, and then we can add songs to the playlist, and as we can see, when we display the playlist, they will show up for the playlist, and then we can rate the song. And then lastly, we can add playlists to the user. So if we add the playlist to user 1, and then we display all the playlists belonging to that user, we can now see that Rafael Volk has one playlist, which is that playlist with all the songs in it.